Well, students, we found the angular velocity of the rigid body as a rate of change of the angular position of any straight line drawn inside the rigid body measured with respect to a fixed reference line. This method of calculation of the angular velocity is known as ground frame method. With respect to the ground, we calculate the angle made by the straight line drawn inside the rigid body between these 2 points with respect to the fixed reference line. Let it be theta. So, your theta is called the angular position. At what rate this angular position is changing? That is what we call angular velocity. These are all vector quantities, but I am writing them as scalar, avoiding the vector sign. However, these are all vector quantities. Since d theta or the elementary angle is a vector quantity, as I discussed by taking the illustration, when it is divided by the scalar quantity, the ratio of the elementary displacement, elementary angular displacement of the rigid body and the elementary time during which the angular displacement is happening. This ratio is defined as angular velocity of the rigid body is a vector quantity. This is the concept of angular velocity in ground frame method. Why it is called ground frame method? Because we define the angular position of the rigid body by drawing a straight line inside it and taking its angular position with respect to a fixed reference line with the ground. Therefore, this method of calculation of the angular velocity is called ground frame method. Before discussing this, I would like to discuss the difference between the angular velocity of the straight line, say, just you can write like that, angular velocity of the straight line. You can take another straight line, let it be 3, 4, straight line A and the straight line B. Angular velocity of the straight line B. These two angular velocities are equal. If you prove that, then you can draw any straight line inside the rigid body. The angular velocity of all straight lines run inside the rigid body are equal to each other. That is what is called, termed as the angular velocity of the rigid body. A simple mathematical way we can prove it. For this proof, we can take two straight lines inside the rigid body at least. There is straight line 1 and that is straight line 2. This is 1. Let the straight line 1 subtend an angle theta with respect to this reference line. Let the straight line 2 make an angle beta with respect to this fixed reference line. The angle between these two straight lines, 1 and 2, let it be phi. In 10th standard geometry, you studied that in this triangle, say A, B and C,